but without going too far from the 380 for ease of transitioning pilots from one aircraft to another. So the basic philosophies of using the cockpit are very similar to those that we had on the A320, 330, 340 and 380, but the look and feel is slightly different in the cockpit. What we've done for the noise and fuel burn issues is that we've incrementally improved our flight management systems so that we can optimize flight trajectories. One of the things that we would like to do, if we were to optimize fuel burn, for example, on the approach, we'd like to start from the top of descent with the thrust and idle, fly the optimum speed all the way down till we hit the runway with the gear down. That would be the perfect trajectory. The problem is, if we arrive at where we think we need to go down, but we don't know quite what the winds are on the way down, and if we find the winds are not what we thought they were and we finish up high, then we may finish up going around, flying another big pattern, another approach and landing, making more noise, using more fuel. So we've got to be careful when we're saving a few kilograms that we don't finish up burning a ton of fuel because we've had to go around. So it's quite difficult to get it perfect, but we've gone a long way, and one of the things that we have on this airplane that we don't have on anything else is that we have a means of seeing where the latest point, or for the optimum point of selecting the flap 1s and flap 2 is in relation to the runway. Now this is Paris Airport 07, and these are the points. About 10 miles out we select the first stage of flap, comes out. About 7 miles out, the second stage, 5 miles the gear would come down, so that we'd be established at around about 3 miles with the... Sorry!
I'm sorry, it's me.
That's okay. That's good. We'd be established about 3 miles, which is about 1,000 feet, with the gear down, ready to land. And that's really the optimum, because if we put the flaps out early, or the gear out early, it creates a lot of aerodynamic noise. It's obviously more fuel burn because we've got more drag. So we want to delay selecting the flaps and the gear. We can't delay it too much, but if we do it too early, then we're creating, burning more fuel, we're creating more noise. The technology is there, and it's improving all the time. We've got a little way to go to optimize it. And I think, from my perspective, the most important thing is to try and reduce holding times as you come into the major airports like Paris or London. And at the moment the average hold time into London in the morning is about 15 minutes. Now if you imagine in 15 minutes you're burning, I don't know, maybe 1.5 tons of fuel. By doing an optimized approach, if you do an approach straight in, you may be gaining 10 or 20, 30 kilos. But if you're burning a ton and a half every time you go into the hold, I think that's really where we will save more, the most, if we can manage the air traffic system better.
And by the way, it's over.
Okay, all right.
Time is over.
Okay, so just one more second. So have you flown? How many approaches have you flown, or what have you done so far, just to kind of validate?
Simulator, and we've flown it ever since we've had the airplane. So yeah, we've flown.